rather than the land which is currently under fertilizer intensive corn production. And so as a result, even though there is about 3 million hectares of land that gets converted to energy crops, it does not displace much of the corn in the Midwest, which is in fact the source of the nitrogen. So we looked at alternative scenarios, extreme scenarios, just to see, what it might take in order to really get those large benefits that we saw from some of the hydrological models. And so if you could have a mandate where no corn stover was allowed, or you could produce a corn stover but not apply any additional nitrogen to it, or if you just had perennial grasses only, you could get additional benefits. And so if there was a distinction between the different feedstocks and only perennials could be reduced, then in fact the amount of nitrogen leaching could go down below the level even with the corn ethanol, and you'd get a much larger reduction. And of course that would require a different type of policy than the renewable fuel standard currently is. So then we kind of looked at other effects of the renewable fuel standard in terms, because nitrogen leaching occurs not just in the form of and impacts not only water quality, but there is nitrous oxides, there is ammonia, there is nitrogen dioxide. There's all kinds of ways that nitrogen, which is applied in agriculture, impacts the environment. And so we looked at some of these effects, and it's sort of a benefit transfer type of an analysis, where we looked at how much of the nitrogen is on average expected to leak out in various forms. And we find that, according to this study, about 71% on average of the nitrogen that is applied leaks out to various environmental, sources. And the costs of this vary depending on the source of the damage. But, the low is sort of a little about more than $5 and a high about $17, sort of an average value of about $10 per kilogram of nitrogen that is applied causes these types of damages. So we wanted to value the damages because of nitrogen leakage. We also wanted to value the damages or the benefits due to greenhouse gas mitigation, which is using a social cost of carbon. And then we wanted to look at the economic costs and benefits associated with it, with the mandate as well, to agriculture and fuel consumers, producers, and so on. And then put that all together and do sort of a social cost benefit analysis to look at what the net impacts are. And so when we do that, we find that with the corn ethanol mandate, there's clearly an increase in corn acreage, corn prices go up by about 12%, nitrogen use increases, emissions go down when we consider both direct and indirect land use change and all of the other impacts. And this is largely because of the reduction in direct gasoline consumption. So there is about a 3% overall reduction looking at these 15 years cumulatively. With the cellulosic ethanol mandate, there is also, of which about half is produced from corn stover, rest from energy crops. There is this increase in continuous corn acreage, which worsens the nitrogen requirements. Corn prices go up, but very little, because there's very little additional diversion of cropland to biofuel production. But there is this increase in nitrogen use. And as a result, there is a decrease in that is almost twice as much than corn ethanol. So there is that decrease in greenhouse gas emissions. But at the same time, there is an increase in the nitrogen, the damages due to nitrogen. And so if we look at overall over here, shown here, the social cost of greenhouse gas emissions goes down. And so that's sort of the net benefit. It's even higher with the cellulosic mandate than it is with just the corn mandate, but there's a large social cost of nitrogen damages. And it's, of course, pretty high, $130 billion over the 15 years cumulatively, using that $10 a ton, a $10 a kilogram value, the middle value of that is in the literature. And it's much smaller with the cellulosic, corn and cellulosic ethanol mandate, but still it is fairly large and offsets quite a bit of the greenhouse gas reduction benefits that one gets. In addition to that, if we look at just the distribution of gains, we find that the main beneficiary of the mandate is really the agricultural sector, and within the agricultural sector, it's the ag producers, particularly with the corn ethanol mandate, and to some extent with the cellulosic ethanol mandate. The big costs on the gasoline consumers, and particularly with this corn ethanol mandate. And so overall, we find that there is a large net cost, if you take into account the economic costs and benefits and the environmental benefits, you find a large negative impact in terms of social welfare with the corn ethanol mandate, and a negative impact with the cellulosic mandate, although it's smaller, over this 15-year period. So we looked at, is this an impact of how we are measuring the benefits in terms of greenhouse gas reductions and nitrogen, looked at different values of the social cost of carbon, $50 and $100, low, medium, and high social cost of nitrogen, and looked at other scenarios. And we find that even with the high social cost of carbon and a low social cost of nitrogen, you still get a negative impact. Of course, the negative impact is smallest if we get a large increase in the price of food crops, because that improves our terms of trade and the cost goes down, but it's still negative. In contrast, if we look at do the same kind of sensitivity analysis with cellulosic mandate, we find that there are a number of different scenarios here where if you have a high social cost of carbon, $100 per ton, and a low to medium social cost of nitrogen instead of the high, then in fact there is a net economic benefit with the cellulosic ethanol mandate. So one would have to really value the carbon reduction at a much higher rate than the nitrogen damages. And also, of course, a lot will depend on what the cost of producing these cellulosic biofuels would be. If those costs go down, then in fact these costs on the economy also go down. So technology would clearly play a role here in terms of what the future costs are going to be of the second generation biofuels. All right. So what does this tell us? Well, for one, it shows that these types of mandates impose significant costs on the U.S. even after we consider these environmental benefits. And this may not necessarily be the case with this cellulosic biofuel mandate, as I said, if the social costs of carbon are high, or if the costs of producing them go down significantly because of technological improvements. These mandates do offer trade-offs between the gains to agricultural producers, but losses on the food and the fuel consumers, and to some extent on the fossil fuel producers. They also could offer a trade-off between reducing greenhouse gas emissions but increasing nitrogen emissions. And these trade-offs are lower depending upon different market conditions, depending upon which mandate and which type of biofuel we're talking about. And in the long run, with the cellulosic mandate, could be lower as the cost of production go down. But in all of this, it's sort of important to kind of distinguish between the role that policy is playing over here versus the role that the biofuel themselves is playing, because in part we know the findings that we're getting is demonstrating a shortcoming of the renewable fuel standard, which is treating all cellulosic feedstocks as identical. It's a threshold based mandate, which basically says if the biofuel is 60% cleaner, then it complies with the mandate, and that incentivizes the lowest cost biofuels rather than the biofuels that offer the greatest environmental benefits, even if those environmental benefits might be coming at lower cost, but there's no mechanism for incentivizing those types of biofuels. And so there's no additional incentive for producing biofuels with the relatively lower carbon intensity or with the lower impact of nitrogen leakage, and that's why you could potentially have this trade-off. So it's seems to be more of a policy failure rather than necessarily a technology failure. And there's a need to think about supplementary policies that would encourage the more environmentally friendly biofuels. An example of that we've looked at previously for the greenhouse gas benefits in particular would be the low carbon fuel standard that actually incentivizes biofuels with a lower carbon intensity. But similar kinds of policies could be developed to look at other environmental impacts as well. There could be standards for residue harvest. There could be standards for replacement nitrogen application, or even looking at nitrogen emissions per megajoule of biofuel as an additional mechanism for inducing the better types of biofuels. So that's that. I'm going to stop with that. Happy to answer questions, but that's sort of the basic message of this research.
Okay, thanks, Madhu. It's really excellent talk. And first, I'd like to see if there are any questions that to Madhu. Justus? Justus, can you ask a question? Okay.
Yeah. So I guess I can read Justus's question. Justus asking about the possibility to check the predictions of the model with the nitrogen leaching data. So, Justus, are you asking about empirically validating the?
Exactly.
Yeah.
To see the predictive power, so to say, of your model.
Yeah. So, the agroibis model is validated under using existing data, and in the paper we have the results of that. And the paper, I mean, it basically shows how well the model does predict the current nitrogen leaching. This is a model that's very widely used and has been around, and so it's a well-validated model. Similarly, BPAM is, we validated looking at by comparing the model outcomes with the observed data in 2016. So we look at how well the model predicts the existing situation in the starting year, and and it does pretty well, very close to the observed data. But then more importantly, for for the kind of work that we're doing here, what is more relevant is that we're using this validated model, but then we're really comparing across scenarios. So the goal here is not necessarily to predict specifically how much would be the economic impact or the nitrogen impact in any given scenario, but it's to look at these differences across scenarios and keeping all other assumptions the same. What is going to be the net impact? And as long as we believe that the outcomes of the model are not in any way shaped by the scenarios themselves or likely to be biased one way or the other in one scenario versus another, it's reasonable to assume that the any sort of missing elements of this are going to wash out when we compare across scenarios. And so that's one way to think of the results of this model.
Do these models have policy relevance in the United States? And I ask this, in Europe we have a very heated debate about nitrogen emissions coming from agriculture. In the Netherlands, in Germany, in those two countries, where this is then linked with direct policies affecting farms based on modeling exercises. And there the challenge then posed to those who do these models by farmers and other stakeholders is, to what extent are these models really correct, measuring or predicting what is going to happen? Do you have something similar in the US as well?
Not really. In the US, we, I mean, none of our agricultural policies are performance based to begin with. They are, like the renewable fuel standard, they're very practice based, and they try to mandate practices without necessarily trying to look at what is the outcome of that. And so there's very little use of models to help to guide policy directly, or as a way to kind of look at measure policy outcomes. I mean, we have impact analysis happening all the time, and with the renewable fuel standard too, but there's really not been much attention to looking at the nitrogen impacts of the renewable fuel standard at all. So I know that, in non-policy circles, there is sort of increasingly an interest in moving away from this practice-based approach to agriculture towards a more of an outcome-based approach. And I don't, we've got these new, movements going on, which referred to as regenerative agriculture, which is a way to get away from practices to outcomes. But it hasn't really made its way up in the policy debates. And except to some extent, I guess the only thing that probably did make its way to policy was this whole concern about indirect land use change that was just purely based on models, to the detriment of not being validated at all. And surprisingly, I think is probably one of the few examples of something that was based on flawed analysis but did affect policy.
Thank you.
So Will has a question about whether we consider the induced land use change impacts the model. Yeah, so we actually do look at indirect land use change in the model. Domestically, we model that within the model itself, but we don't look at indirect land use change internationally. So and so that hasn't been included over here. Again, that would most of the recent estimates for the indirect land use change have been declining substantially in their magnitude. And so the most recent work with the GTAP model that you've probably seen, has brought that number down from the original 104 grams of CO2 per megajoule to 8 grams of CO2 per megajoule. And that's with corn ethanol. With the cellulosic ethanol mandate, it would be very, very small, because there is most of it, as I said, is corn stover, and the rest is energy crops, but they're going to have a hard time competing with actually diverting productive cropland. So it's not going to really displace a lot of food crop production in any major way. So.
George, there is a question to you about.
Well, I had a question, David. I don't know if you can hear me. I had a question for George about we've for 2 days now we've been hearing about the environmental impact of the bioeconomy, particularly from the South Americans. And so I was sort of curious, looking back at your report, to what extent they talked about environmental issues and things like that.
I'm going to answer this very diplomatically. That one of the things we point out in the report is that in like things like defining and measuring the bioeconomy, other countries place a greater emphasis on adapting to and mitigating climate change.
Mm-hmm.
That they've emphasized that in contrast to the US. We talk about the importance of the bioeconomy as a way of adapting to climate change. Also, we talk about it as, as a mitigation issue, and especially in the case of if you're shifting from fossil fuels to renewables, the potential that if you're just looking at something like GDP, you're not going to necessarily see something, but if you're looking at the environmental effects, that you would. But the questions we were getting from the sponsors were not particularly focusing on environmental effects. So it's not really something we addressed. There's things throughout the report about it, but there wasn't really much in the way of trying to formally measure the environmental effects.
Well, maybe if there's a change in administration, you can do a follow-up. And look at.
Right. Well, that's another reason why the committee recommendations that I emphasized today were being welcoming to foreign students, and having more multilateral cooperation.
Okay, thanks.
How much, when you look at the bioeconomy, obviously you spoke about the present, but the key in the bioeconomy is only starting. Did you try to see what is the potential, especially when you look at risks, what is the potential of growth of the bioeconomy and improved productivity? And actually the same thing is to all the speakers, what is the potential, we speak about future technologies, what is the potential of learning and how changes in technology can affect your conclusion, all of your conclusions?
We actually focus quite a bit about the future. I mean, in the very calculations, there's different columns of results for kind of the bioeconomy as of 2016 and the potential. And there's the report has a lot of exercises kind of looking out and trying to track out what the what developments are in the future, and is very explicitly trying to be forward looking, and there's one whole section that's trying to there's one whole section that's trying to trace out the future path.
But there is any bottom line that you can tell us? It will be radically different?
I think there was an initial question about there's this big push for cyber biosecurity as different from just cybersecurity. What about biological data is different? And it's it's not all that different, and that there's a lot of trade-offs that we face now that are in terms of you want to have innovation, you want to have openness, but there's intellectual property incentives, there's national security incentives, and there's a tug of war there, and it's just that's going to be a continued thing. I think one thing that surprised me was that again, I'm going to be kind of diplomatic, but just in general, in terms of other outside folks asking questions about the bioeconomy, there's kind of a mercantilist stance. It's how could we position ourselves to be better, as opposed to kind of a more international cooperative, productivity growth helps everybody everywhere. And so as time went on, it kind of shifted from the questions we were getting from outside were from kind of less of a mercantilist approach and more toward international cooperation and just furthering science and productivity growth in general.
So yeah, so I mean, that's a difficult question to answer, because at one end there's a huge potential in terms of our ability to produce these bio-based fuels and products from these high-yielding feedstocks that we know how to produce. And there's also, I don't think that, at least in the US, land is going to be a major limitation, given the fact that these are so high yielding. And as productivity growth continues elsewhere in agriculture, land is going to be, freed up. And so we know that land is, the need for cropland is declining. That land could easily be used to produce, quite a bit of bioenergy. I think the main challenges are technology and markets for this. And so, um, I think we're still quite a ways away from actually having commercial scale production, competitive, even with to get it down to like corn ethanol levels of cost. Um, and to be able to do that on a large scale, um, there is sort of work looking at, well, we need to look beyond biofuels at other bio-based products that could be simultaneously produced and you get more value from the biomass. But again, we know how to do that, but being able to do that on a large scale is still limited. And and then there's a question of the market for it. If we're going to just rely upon when these things become competitive with the declining price of oil, I think it's going to be even harder. If we were able to have policies that penalize carbon from gasoline and so on, maybe we could do it, but you need very, very large carbon prices to do that. So we need fairly deliberate and proactively developed policies that actually move us towards that. And I guess it's good to see this report looking at how do we safeguard it. But I think that was also sort of going to be my question to George, in part, that was there much discussion about that? What do we need to do to really wean us off fossil fuels and move towards a bio-based economy?
I had a couple of observations, David, if there's still time. Yeah. So just on your question about knowledge, I think all of us are pretty positive on the role of improving knowledge and technology productivity. Look at the staggering developments that have happened in things like the cost of solar and the cost of wind power over the last 20 years. These are things I would never have anticipated at all. People have focused energy on that and got staggering reductions in costs and improvements. And then, of course, the technology of using it is just really getting going with things like, your Teslas and so on. Transport seemed like one of the most difficult things to lower emissions. With pure emission reducing technology, I see a bit of a focus on that, with livestock products, especially what the New Zealanders are doing. They're terrified of this. Their green credentials get blown apart when you look at the emission intensity of their economy, and especially of their exports. But I would hope that something can be done to lower emissions. It may require biotechnology to do it. Presumably a CRISPR scissors could cut through some of that staggering amount of emissions that come out of the ruminant, beef, and particularly beef and dairy products. The other thing is technological improvements of a conventional kind that lower the cost, suffer from the rebound effect that we illustrated when you focus on production. As productivity improves, we use more and more of it, as Jevons observed with coal in the 19th century. But in agriculture, there's the land use change side. If you can, as David mentions, if you can lower the footprint of agriculture, especially in an environment of slowing population growth, if you can save chopping down big chunks of the Amazon, if you can start to allow reforestation in many areas, the type we've seen, say, in New England in the last 100 years, then you get, I think, a much more encouraging picture. I don't know the answer just yet, but it's one that we're looking at in our second phase of this work.
William, I'm sorry to cut you off. David, we have 3 minutes on the server before we get kicked off, so it would be wise to wrap up.
Okay, great. I really like to thank everyone. Maybe we have, I give each of the speaker about a minute to summarize what is their finding and what do they think should be the next stage in the work, and then we wrap up and thank everybody. So maybe George?
What I would say quickly is that if you look at the evolution of this report and the safeguarding, there were various National Academy workshops that started, and it was really more about data and medicine. And it really, as it transformed, looking at the whole bioeconomy, issues about like the environment and agriculture literally were not in the initial concerns of people who were doing activities before the report, and the importance of the environment and agriculture, genetic resources, came more to the fore as the process of writing. And I think that emphasis and also the contribution and influences from people in Latin America and Europe were really instrumental in moving in that direction.
Will?
Yeah, just very briefly. I mean, there are simple solutions to these challenging problems with agricultural and land use emissions. I think our work so far has shown that just getting rid of the subsidies, just getting rid of the market access barriers would not actually help. We need to be much more sophisticated, look at the multiple goals that we have: economic efficiency, poverty reduction, resilience, emission reduction. Look at smart ways using biotechnology, for instance, of reducing both the emissions and improving poverty reduction, economic efficiency, and all our goals. Thanks. And thank you very much for a great session.
Yeah, so basically, I think what I'd sort of sum up is that, second generation biofuels are very promising, can provide environmental benefits and economic benefits, particularly if you're looking at energy crops. But at least in the near term will require policy support to get them going, and how we design those policies can make a huge difference in terms of how much of those benefits we realize, at least in the near term.
Okay. Thanks everybody. It was a great session and I really appreciate it. Okay. And thanks the organizer.